Hello again. We're going to be looking at solving equations that are a little bit more difficult today, equations with brackets and equations with fractions. We're going to start with the brackets ones because actually, although they look more difficult, they aren't really much different at all. So let's do a couple of examples of those just to make us understand how they're not really too hard. When you have brackets in an equation, all you need to do before you solve it is to expand the brackets. And after that, you solve it like an ordinary equation. So here, this is a straightforward expansion. Two lots of 5a is 10a minus two lots of 2 make 4. That's expanded that bracket. Equals two lots of 3a make 6a and two lots of 4 make 8. So we've expanded the brackets. That's the first stage of the equation. Now we need to start rearranging it. We're going to rearrange the letters first. Now just to point it out, I'm going to leave the 4 there and I'm going to leave the 8 on that side. We're going to remove the 6a from this side, which means it becomes minus 6a. 10a minus 6a is 4a. 4a minus 4 equals 8. Now, keeping the 4a, because we've dealt with that, we've got to get rid of this 4. That means take it up to 0. It means to add 4. So add 4 to this side as well. 8 plus 4 makes 12. 4a makes 12. So if 4a's are 12, 1a must be 3. And that's it. So it wasn't any different, was it? It wasn't any different to doing an ordinary equation, apart from that we had to start off just by expanding the bracket. Now sometimes the numbers are a little bit less friendly, and so I put this one on here to show that it can be a bit more difficult at times. Start off by expanding the bracket again. 6 4s are 24, so that's 24a, plus 6 5s are 30, equals 6 9s are 54, 54a, plus 6 6s are 36. Now, when we rearrange this equation, I don't like what's going to happen there, because we're going to be subtracting 54a from 24a, and that's going to take us into a negative number straight away. Personally, I don't like that. So what I do when that situation arises is I just swap the entire picture around. All of that there is going to go on the first side. Okay, and all of this is going to go on the second side. Now, if you're wondering why haven't we started doing negatives and things, think of it on much simpler numbers. Let's imagine 2 plus 3 equals 4 plus 1. They both make 5, don't they? If I wanted to switch that around so that they both still make 5, I wouldn't be making anything negative there, because I haven't altered the entire package of what's on each side of the equals sign. It's only when we start moving bits away from one side to the other that we have to start messing around with signs. Okay, so that's why I've just flipped it. Now, 54a take away 24a makes 30a. Okay, I've done that to remove the 24a there. I've taken 24a away from that side, so I must take 24a away from this side. I'm not going to change the numbers at all yet, because if you do it in steps and it goes wrong, it's much easier to work your way back. Okay, we've dealt with the a's, so 30a's equal. Now we've got to move this 36 away. That means take away 36 from this side. So we've got to take away 36 from that side, which leaves us with minus 6. 30a's make minus 6. Now that means that 1a actually equals minus 6 divided by 30. And that's not very comfortable at all, but it's correct. We can simplify it by halving everything, and we can simplify it again by dividing everything by 3. Okay, there is 1 3 in 3, and there's 5 3s in 15. So A equals minus 1/5. That's a little bit less comfortable. That's why I did the question. Okay, 30 A's make minus 6, and therefore 1A is a 30th of minus 6. And that's how it works out. But again, you can see that you just start by expanding the brackets. I've made an alteration there to make it more comfortable. Still ends up awkward. It would have ended up awkward whatever we did, but that helps us to get a little bit further forward and to simplify things before we get into complicated negatives. All right, let's take a look now at something with fractions. These are a bit harder. 3/4 of n minus 5 equals 9 minus n. Good grief. What do you do with this? Well, the main thing that you've got to notice here is that something has been divided by 4. And because that something there has been divided by 4, and we really don't want a fraction in this question, the best thing we can do is we can multiply absolutely everything by 4. So times 4 for all of it, because we've got a divide by 4 to start with. So what does that mean we're going to do? It means we're going to do 4 lots of 3/4 of n minus 5 equals 4 lots of 9 minus n. And what that means is that 4 lots of this, if we're going to multiply this by 4, we're getting rid of that divide by 4. So that's going to become 3n, okay, the 3/4 times by 4 has become 3n minus 4 5s are 20 equals 4 9s are 36 minus 4 n's are 4n. And now it looks much more like a regular kind of question, doesn't it? What are we going to do with that now then? Well, let's see. I'm going to take away the 4n. Sorry, I'm going to add the 4n to the 3n because it's a minus 4, isn't it? So in order to make that disappear from this side, I've got to add 4n. So I've got to add 4n to this side. So that's going to be 7n minus 20 equals 36. And then to get rid of the 20, I've got minus 20 here. To get rid of it, I have to add 20. And therefore, I've got to add 20 to this side, which would mean that 7 n's make 56. So 1n must make 8. Bottom end of it, I'm not going to explain at all anymore because you know how to do that. But the top end of this question, you've got a single denominator there. If you've got a single denominator in the entire question, multiply everything by that denominator, and then it turns straight into an ordinary equation. Okay, what if you haven't got a single denominator? What if there's more than one denominator? Like that. You've got a denominator of 3 on the first side and a denominator of 4 on the second side, and that's a little bit more complicated, isn't it? Well, actually, it's not too hard. When you're adding and subtracting fractions, you get used to the cross multiplication idea, and you've got to use the cross multiplication idea on this as well. So you've got 2 different denominators, and what we're going to do is we're going to multiply the top, the numerator on this fraction, by the denominator on this fraction. So that's going to become 4 lots of a minus 4. And you've guessed it, we're going to now multiply across this way and make this 3 lots of a plus 2. Now it's a straightforward sum, straightforward equation. 4a minus 16 equals 3a plus 6. 4a minus 3a would be a. oops, excuse me, a minus 16 equals 6. A equals, it's going to be 16 plus, or 6 plus 16, isn't it, which is 22. And that's it. That's completed. How do we know that's right? Because 22 seems a strange number for it, so let's take a look at how we would plug that into our question. Because what we would have is, back in the question, if a is worth 22, the first part would say 22 minus 4 divided by 3 equals 22 plus 2 divided by 4. What's 22 minus 4? 22 minus 4 is 18 divided by 3 equals 22 plus 2, which is 24, divided by 4. 18 divided by 3 is 6. 24 divided by 4 is 6. So it's correct. So there we are. When we've got two different denominators, we cross multiply, and that cancels them out completely. Okay, rather than trying to divide all of this by 3. It's a little bit like when you're multiplying, you sort of do the 3 4s are 12, and then you cross over there and you put the same denominators in there. You could kind of do it that way, but you don't need to with an equation, because you just make your numbers bigger and unwieldy. Just do a straightforward cross multiplication, and then you get your answer. I hope that's helpful. It is complicated when you do fractions with equations, but basically remember those two rules. If you've got a single denominator in the entire question, multiply the whole question by that number, by that denominator. If you've got two of them, two denominators, cross multiply. Multiply the left-hand side, top side of your fraction by the right-hand side denominator, and the other way round. Complex, but I hope it helps. Look in the book. If not, there are more examples in the Maths is Not a Mystery Solving Equations 2 book. And good luck if you get one of those questions in your exam. Thanks for watching. Goodbye.